Hi Year 7, this is Mr Collins. We just wanted to say from the Science Department, well done to all of you who did the assessment last week. We're really impressed with the amount of people who managed to get online and get it done, so well done. I'm going to be going through it and letting you know what the right answers were, just so that you can figure out where you went wrong in your assessments. So the first question, we want to separate out the coloured water from the cabbage. How are we going to do that? We want to let the water through but catch the bits of cabbage. That's filtration. So using a filter, that's going to be how we're going to separate those first two mixtures. Now we've got more than one coloured substance, and to separate those we need to use chromatography. You might remember doing an experiment with a bit of filter paper where the colours all made pretty patterns. Separating out those colours, that's chromatography. The next question, we've got this table full of information which we're going to use to answer these next two questions. We know that the mixture turned blue. If we look in the table, the blue things are alkaline. So that's a good indication that it's going to be an alkaline, and that's the answer to that question. We're adding lemon juice, which is acidic, and acid goes red. So what colour would it be? It would go red. What's the name of a chemical which changes colour based on acids or alkalis? That's called an indicator. Indicators are things that change colour based on whether they're an acid or an alkali. Next question is saying which one lost the most heat? Well, if we look here, that's lost 200 joules, 1000 joules, 3400, 4000. The one that's lost the most heat is the walls. The next question asks you to explain which part of the house has been insulated. And we can see that the part of the house that's been insulated, well, these three numbers are still the same, whereas this number has gone down to 700. So to explain why, I don't know why this is in a different order to your questions, but to explain the answer to this question, it's gone down from 3600 to 700 joules. That tells me the roof has been insulated. Which fuel releases the least energy? Well, if we look at here's the amount of energy released and here's types of fuels, and we can see the smallest number there is 25,000, which belongs to coal. Methane can be compressed. How do we know that? Well, if you look here in the table, here we've got the physical state, and it says methane is a gas. Gases are the only state of matter which can be compressed. So we know that methane can be compressed because it is a gas. Sulfur dioxide causes acid rain. How do we know that methane doesn't produce acid rain? Because if you look over this column, we can see that methane does not produce sulfur dioxide. There's no sulfur dioxide being produced by methane. Right, here's a different experiment with some of the pendulum, a number of how long the string is and how many swings there are. What happens to the number of swings when the string gets longer? Now, lots of my class certainly were there using the word decrease. That's really good to see. Well done if you're using that word, that good scientific language. But any answer here which talks about the fact that as the string's getting longer, you're getting fewer swings. There are less swings, there are not as many swings, it goes down. Those are the right idea. The best way to express it, though, is to put it decreases. Just those two words are all you need in that question. Paula made a pendulum from a piece of string that was 15 centimetres long. How many times would this swing in 10 seconds? Well, 15 would be somewhere between 10 and 20. So it's got to be less than 16, but more than 11. So any number from 12 to 15 is going to be an acceptable answer there. Then she made one which was 60 centimetres long. Well, that's longer than any of the ones we've got in our table, so we're going to have to guess at how many swings. Well, we can see a bit of a pattern here. It's going down, and recently, in these last few, it's been going down by 1, 9 to 8 to 7. So if you make it 10 centimetres longer, I think it's most reasonable to expect it to go down by 1 more, which is why you get to the right answer of 6. The pendulum stops moving. What force makes it stop moving? There's two you could write here. You could talk about friction, or you could talk about air resistance. Either of those would get you the mark. So here now we've got an aeroplane. Which arrow represents air resistance? We see the direction of flight. It's flying that way. Air resistance opposes that motion, so this is air resistance over here, B. It then says it's staying at a constant height. Now, constant height means it's not going up and it's not going down, so which two forces must be balanced? A and C must be balanced. Now they say it's going at a constant speed in the direction shown. So that's the direction, so it's going at a constant speed. It's not speeding up, it's not slowing down, so those two forces must be balanced. So for this next question, it's D and B. Just before takeoff, the plane is speeding up along the ground. So if it's speeding up, if it's getting faster, D must be bigger than B. If they were the same, it would be going at the same speed. You need to have a resultant force to have something speeding up, to have something accelerating. So D must be bigger than B in order for it to accelerate. And that's the right answer for that question. Which statement is true about the plane just as it leaves the ground? So now we know it's going to start going up. Well, if it's going up as it leaves the ground, A has got to be bigger than C, otherwise it would just stay on the ground. That force has got to be bigger than that force to make the plane go up off the ground. So for this question, it's A is greater than force C. So in this question, we've got a graph of a cyclist with points labelled on it. Which points were they moving fastest? So this is about the gradient of the graph. So you're looking at the steepness of the line, and the steepest part of this graph is between C and D. That has got the highest gradient, the steepest part of this distance time graph. So between C and D is the right answer. State one way the cyclist could reduce air resistance acting on them. Well, there were lots of possible answers here, but the simplest thing is lots of you, in my class at least, wrote about crouching down so that there's a smaller surface area. But that idea of crouching down or wearing tighter clothing or wearing streamlined clothing or a streamlined helmet, there were lots of right answers here. I'm not sure it was actually in this order when you took the test, but that question was in there and that is the answer to it. How long did the cyclist stop and rest? Well, if I look at the graph, there's a portion of the graph here where the distance isn't increasing, and that's between B and C. And you can see B is at 1 hour and C is at 1.5 hours. So what's the time to go from 1 hour to 1.5 hour? It's half an hour or 30 minutes. This one was really tricky. Okay, so this was a 3-mark question. This first bit wasn't. Write down the equation that links distance, speed and time. Speed is distance divided by time, speed over time. There's lots of ways of rearranging that, but that's the equation you needed. Here we had to calculate in kilometres per hour the average speed of the cyclist while moving. Now this bit was the hard bit. Now the clue here is kilometres per hour. So you need to know the total kilometres and the total time. Now lots of you looked at the graph and went, well, that's easy. Just this point here tells me the total time is 4 hours and the total kilometres, oh, well, that's about 56 there. If I read that off that graph, 56 divided by 4, that gives me 14. Now, the trouble is you've missed part of the question. Part of the question says while moving. So you need to ignore this bit here where they're not moving. So the total time is actually only 3.5. And when you divide those down, you get an answer that instead of being 14 is actually 16. Okay, so the last question about magnets. 2 electromagnets, how do you know they're the same strength? Because they are picking up the same number of paper clips. They both pick up 4 paper clips. That's indicating they're the same strength. Why are we using iron instead of steel? Again, there's quite a lot of ways of explaining this, but the basic idea here is when we've turned the power supply off, iron stops being a magnet, but steel stays being magnetic. Now, that's what we want. An electromagnet, we want to be able to turn on and off. Think about using in a scrapyard, picking up a car. You don't want, once you've picked up a car, never to be able to put it down again. That's what you'd get if you made the core out of steel. By making it out of iron, you get a magnet you can turn on and off. So the key idea here is that iron stops being a magnet when the current stops, whereas steel stays magnetic. There's lots of ways of expressing that idea, but that's the key idea that you needed to express to get that mark. Okay, this was a slightly complicated question. Let's talk quickly about what this graph shows you, because if you understand what the graph shows you, you'll understand the question, how to answer it. So we're doing an experiment where we're changing the amount of current and seeing how strong the reading is on the sensor. That's kind of a measure of how strong the magnet is. So up here, the magnet's really strong, down here, the magnet's really weak. And you can see on both of these lines, if we have more current, the magnet gets stronger. It increases the strength of the magnet. But you can see if we're really close to the magnet, you get it much stronger. And if we're further away from the magnet, 50 millimeters from it, then you get a weaker magnet. So it's the same magnet, just we're putting the sensor at different distances. What that tells you is, for this question, how did the distance of the sensor from the electromagnet affect the reading? So the further away the magnet was, the sensor was, the weaker the magnet was. So when it was 50 millimeters away, further away than 25 millimeters away, the magnet was weaker. So my answer here would be something along the lines of, when the sensor was further away, the strength of the magnet decreased, or as the distance increases, the strength of the magnet decreases. Again, using that scientific language, that's your best answer there. How did the size of the current in the coil affect the strength of the electromagnet? As the amount of current increased, the strength of the electromagnet increased. That's my answer there. Again, using that best language there, talking about increasing and decreasing rather than getting bigger and getting smaller. What else could David do to an electromagnet to change its strength? Well, there's two things we can't say, because it says what else could David do. We can't talk about the current, because that's already been part of this experiment, and we can't talk about the distance, because that's already been part of this experiment. So anyone who wrote those answers, that's why you got those wrong. It's because of that word else. Instead here, what they want you to do is think, what other things can they do which will make the electromagnet stronger or weaker? So the best things to talk about here are adding or removing coils, adding or removing a core, or changing the size of the core. Any of those kind of answers, those are the key things you need. So well done for getting to the end of the video. If you still have any questions about any of those that you're still not sure, please get in touch with your teachers and I'm sure they'll help you out. Well done again for taking the test, and keep on learning through Google Classrooms, and stay safe out there.